Okay, good afternoon, everybody. I'm Paul Quinn, Network Manager of Industry 4 SkillNet. Welcome everyone to the third webinar in our series, Industry 4 and the Digital Revolution. This week, we're going to continue our journey through the fourth industrial revolution and how Irish companies can adopt and engage in these emerging technologies. This week, we'll cover cybersecurity. Who knew that would be a thing? Additive manufacturing, big data, and artificial intelligence. That will feature our special guest, Ian Keaney of Skellig AI. I hope you enjoy today, and I'm going to hand you over now to Billy. Billy, welcome to today, and how are you doing?
Good, Paul, thank you. I'll just share my screen now. Okay. So what is Industry 4.0 and the digital transformation? My name is Billy Schofield, and I've worked in advanced manufacturing for the last 37 years. And I'm going to share with you some of the things I've learned about Industry 4.0 and the digital transformation. So again, thank you for attending this webinar today. And thank you to Paul Quinn and the SkillNet team for inviting me to talk with you. At the end of this webinar series, you'll have a much better understanding of the Industry 4.0 concept and how to apply it in your setting. So this is webinar 3 of a series of 4, and each webinar runs live at 1:30 p.m. On Thursdays, Irish time. The webinar series is called Introduction to Industry 4.0 and the Digital Transformation, a series of 4 webinars. So we've already covered webinar 1, where our guest speaker was Dr. Ali from IT Sligo. Last week, we covered webinar 2, where we had a guest speaker from some Virtua, Mr. James Corbett, who spoke to us about augmented and virtual reality. And this week in webinar 3, as Paul has already mentioned, we'll be talking about cybersecurity, additive manufacturing, and big data. And I'm super excited to have our guest speaker this week, Dr. Ian Keaney from Skellig AI, who's going to talk to us about what's happening in the world of artificial intelligence. I'm intrigued to hear this talk because I think artificial intelligence has changed a lot since I first seen it back in the 80s. I remember writing programs in BASIC in the 1980s, trying to advise technicians and operators what adjustments to make to tools with these little basic programs. We called those expert systems then. Then in the 90s, we seem to have regressed a bit by the 90s, and we were using lots of paper response flow charts that all the technicians had, and they would look through these to decide what to do next on the tools based on the engineer's best experience. But I think that things have evolved significantly from then. We'll be finding out from Dr. Keaney on where we are with artificial intelligence and how it can be applied in the modern day industrial and operations setting. Then next week will be our final of the series of 4, where we'll look at future trends, and our guest speaker will be Brian Cooney from KUKA Robotics, telling us about the latest advances in robots and cobots. Of course, all these webinars are recorded and are available on Industry 4.0 SkillNet YouTube channel. You can access them all for free if you have signed up for the series of programs, so you can watch them at any time in the future if you want to go back over the content. So they'll all be posted on the YouTube channel, and you should all have access to that. So our agenda today, we'll be doing our introduction, and then we'll talk a little bit about cyber security and what's happening in the world of cyber security. Additive manufacturing, also known as 3D printing. We'll have a talk about that. These are all tools in our Industry 4.0 toolbox. We'll talk about big data. What is big data and how can it help us? And again, our guest speaker today will be Dr. Ian Keaney, who will be talking to us about artificial intelligence. Again, we'll be doing a Mentimeter survey today, voluntary survey, just for fun. And if you don't want to take part in it, you don't need to, and it's all, the data's all anonymous. So if you just have a tab on your laptop or on your smartphone open at www.menti.com, I'll share with you a code later in the presentation for you to take part in this voluntary survey. So through the last two webinars, we've been talking about the Industry 4.0 concept, and we've been looking at the model of the Industry 4.0 factory. So we've spoke about one of the key concepts of Industry 4.0 being the smart or connected factory, a factory where all the equipment and machines in it are fitted with sensors. They can gather that critical data and upload it into our central IT databases through the internet, where we can analyze that data, apply AI to it, make decisions on it, produce dashboards, and do real-time adjustments to the equipment on the shop floor. We then spoke about cyber physical systems, which is one of those systems which where we gather the information and data from the equipment, and the system can be automatically adjusted. The physical system can be adjusted based on that data, and that's what we refer to as a cyber physical system. And I shared with you the example that I gave about a pump, me having to gather data off a pump and then decide what adjustments I would like made to it. But in a cyber physical system, that data can be automatically collected, and the pump can automatically be adjusted on that data. Last week we spoke about cobots, collaborative robots that collaborate with human beings to achieve tasks. And the concept here is that machines should be adapted to help human beings rather than human beings adapting to the machines. So the cobot is about a machine that adapts so it can assist its human operator. It doesn't work behind some cage, it's working in the same workspace as its human operator. And last week we had a look at some of the advances that are working in the world of surgery, some quite extraordinary stuff there. Then the last concept we spoke about last week was the area of decentralized decision-making, often forgotten about in the Industry 4.0 framework, but a key area, and it's about employee empowerment. How do we enable our employees to make quicker and better decisions as they have more and more information and data available to them? And then we look at the tools that are in our Industry 4.0 factory. Last week we spoke about digital twins and augmented reality. This week we'll have a look at cybersecurity, 3D printing, data analytics, and we'll be doing a deep dive this week on artificial intelligence. In webinar one, we did do a poll asked you the question on what Industry 4.0 areas is your company focusing on. We now know that the key focus areas from the group is data analytics, the smart factory, and cybersecurity. And when we compare that information to other groups that I've polled earlier this year and to a larger poll I've done a number of years, these are fairly consistent across Irish industry: data analytics, the smart factory, and cybersecurity being the top three. Last week I asked you the question, Do you or your organization utilize or plan to utilize in the near future digital twins, decentralized decision-making, or cobots? And 43% said, yeah, we were going to utilize digital twins, 29% on decentralized decision-making, and 14% on cobots. So an interest there in the area of digital twins. We've done some work on our whiteboard over the last two webinars where we've spoke about the four industrial revolutions, the impacts of them, what is digital cyber-physical systems, employee empowerment, cobots, digital twins, and we've looked at our Mentimeter poll data. So today we'll add more information on this when we do our whiteboard work today. So I'd like to talk to you about the first topic on the agenda today, which is the area of cyber security. So protecting systems from cyber attacks is critical in the Industry 4.0 setting, as everything is now connected. In the smart factory, everything is connected. All our shop floor tools, all our machines are all connected together through the internet into our IT systems. So protecting those systems from cyber attacks becomes even more important. And the type of threats that we are subject to is data leakage, social engineering, vendor risk, and hacking. All this information, people either trying to damage our systems, steal our information, or prevent us from making progress. So we need to protect our assets and our intellectual property. And we can do that by protecting our IT systems, our information technology systems, and also our operational technology systems. Those are all those tools and all machines on our shop floor that are connected in the smart factory. We also have to protect those at the OT, the operational system level. And if you have products which you are tracking it with your customers, like the car manufacturers now have as they go for autonomous cars, there's a lot of customer technology in the car reporting back to the car manufacturer. So the car itself, the customer technology needs to be protected as well. Now, IBM did a recent survey of companies on cyber attacks, and specifically looking at it from a smart factory, industrial Internet of Things point of view. And what they found was that 36% of executives say that securing IoT and smart factory platforms is a top challenge for their organizations. So this is a new and emerging concern for organizations, with 36% of executives recognizing it as a top challenge. So this is a shared problem that many organizations are facing today. And 30% of cyber attacks from this survey were identified at the OT, the operational technology level. So not at the IT level, but cyber attacks at the OT, the operational systems level. And in the Middle East, 50% of all cyber attacks are against oil and gas industry, maybe not surprising. And we did see that big cyber attack in the US a few months ago that prevented some, oil pipelines making their oil deliveries to different storage areas. And that was an attack at the OT level. So we remember our smart factory that we spoke about in webinar 1. In the smart factory, we have our things layer, where all our machines on our shop floor, the things, we call that perception layer, and that's where our operational technology lives. We communicate that through the abstract layer into our IT systems and our applications, where we have all the applications we use to help us make our decisions. And we possibly have a 5G network driving that if we have a wireless option. And we have some edge computing where we're bringing edge computing decision making closer to some of our factory machines. Now, a great deal of effort has been put in improving cybersecurity at the applications and IT layer, and many of us use cloud computing solutions for that, and there's very good security offered by the cloud computing companies such as AWS and Microsoft. But the emerging risk lies down at this layer, the operational technology layer, and that's where the emerging risk is, and that's where many companies are starting to put their efforts in on protection for cybersecurity, and in the edge computing area as well. So I'd like to go to my whiteboard, and I'm going to ask you a question. How can companies mitigate against cyber attacks? What can we do to mitigate against cyber attacks? And I'm just going to capture some of this on my my whiteboard. So I'll stop sharing. So Dara, if you can put your answers into the chat box, Dara, if you can call them out for me. I'll just switch off my background. Okay, so how can we mitigate against cyber attacks? What type of things could we do?
So one of the first ones we have here, Billy, is regularly educate our employees.
That's a great one. Education of employees. You know, we really need to bring the employees with them and know what their responsibilities are and what they can do to protect the company's assets. That's a great one. And even when it comes to sharing information from an intellectual property point of view, what do you put on your LinkedIn page? How much information should you share about your job? Even that's important, and it's something we can help educate employees on. In fact, the whole people side of cybersecurity is a real key area.
Another one we have here, Billy, is to take an inventory of current OT assets as a start that can be impacted by cyber attacks.
An inventory of OT assets, yeah. Yeah, so take what have we got, start with where are our risks. It's a great place to start. Where are our risks? What OT assets have we got out there? And start to think about here's what the risk profile looks like for our company.
Another one is firewalls.
Firewalls are fantastic. Yep, firewalls have been highly effective for many years now in many organizations in protecting their data breaches and hacks of their information. So firewalls are fantastic and continue to be strengthened, and is a real key tool in the cyber attack arsenal.
And another one here, Billy, that I think is interesting is not to download from unknown sites, which would fall under the phishing. And I think I heard before that something like 80 to 90% of all cyber attacks come from human error.
Yeah, phishing. That's a huge one. Don't click on those unknown sites, and that is one of the most common ways that cyber attacks happen. Is that somebody receives an email saying, "Here's an important link you need to get information from," and you download it, and then you've loaded some malware into your company's system. So that is a real important one. And actually, we see it in society all the time. The amount of junk email I receive that is obviously phishing is incredible. So awareness with employees around what links they should open and what they should not open is really critical. Any others there, Dara?
Yeah. Performing a risk assessment of your company's current ability to deal with the cyber attack.
Yep, risk assessment. What is our current ability? Are we really vulnerable? Do we have very little in way to protect us? What are our risk areas? You know, get the high risk ones on the table and start to think about plans, things that you could do to reduce the risk, to reduce the vulnerability your company has.
Yeah, another one here is to encrypt sensitive information.
Encryption, yeah. That's a great technology tool to protect. Encryption is really important and has been, again, another highly effective tool against cyber attacks.
And also to build a crisis management profile, Billy, or program rather.
Yep. Yep. What do you do when you get a crisis, when you've got an event? What are you do? Do you have a set procedure? Do you have a war room, a way of responding to an event? So that should be all planned up front, so that when an event occurs, you have a crisis management program that's there and ready to help you respond to it. So they're all great examples of ways to mitigate against cyber attacks. So I'll just go back to my presentation just now. So I'll just start sharing my screen again. So we've seen some great examples there of things that you could do to mitigate against cyber attacks. So again, IBM in their recent survey did ask companies what were the top things you could do to mitigate against cyber attacks, especially in an IoT smart factory environment. And the top three that they got from the respondents was, first one was purchasing insurance. It's not really a mitigation, it's more of a, you know, deflection. Doesn't really solve the problem in any way, it just financially protects the companies. So many companies do purchase insurance around cyber to financially protect them against a cyber attack. The other one was contracting with third parties that provide risk mitigation. So bring some experts in to help you set up protection against the probability of a cyber attack. And then form cross-functional teams, security teams across your organization that can be there to help with improving your cybersecurity. And I think that was one of our examples that we had. So if we look through those examples that we have from IBM, we see that purchasing insurance, that's a very common one. Not really a solution, just for financial protection. The second one was contracting with third parties to provide risk mitigation. So bring experts in to help your organization. Set up a cross-functional security teams, which might involve, your IT security, your operations people, your vendors, a cross-functional group who's responsible for security. Get all your scanning on all of your connected devices. Make sure that they're scanned for viruses and malware continuously. Reduce your surface attack area. How can we mitigate and reduce the area that we're vulnerable in? Deploying devices with diagnostics to detect malfunctioning caused by failing components. Cloud security solutions. We're often storing all of our data in the cloud now, and that can be a very secure way of protecting information. So using cloud security. Having a security operations center for monitoring, an ops center who's responsible for cybersecurity and monitoring the organization. And it was one of the first ones we got on our list today was increasing employee visibility on security operations, educating and bringing our employees along on the journey with us. Centralized coordinated patching and updates, have a central organization responsible for making that sure is rolled out to all the equipment in our environment. Performing cybersecurity breach simulations, what happens, run a simulation, do a test study, find out, do a drill, we've got a cyber security attack, do a real-time drill with employees and test your systems. How robust are they? We can talk about things and we can read books and we can listen to webinars, but the real learning happens when we're doing something, and that's why running simulations is so important. Make sure the data we're putting into systems is clean. Having SLAs in our organizations on security and privacy, and continually monitoring our Internet of Things traffic to find anomalies and assess for vulnerabilities. So they're all great examples of how we can mitigate, and they're the top ones that when IBM polled organizations very recently on what they were doing to protect themselves from cyber attacks in a smart factory, connected factory environment, these were the top ones that came out. I must admit, I was surprised by the purchasing insurance. I hadn't even thought to me that, that I would have included that in my arsenal of things to do to protect myself. As far as protective technologies that we can use to protect ourselves against cyber attacks, the top three from the same audit came out as threat detection software, network security improvements, and encryption. And we had encryption on our list that we looked at 5 minutes ago. So we have a good understanding of many of the things we can do to protect our environment against cyber attacks. And it's a new and emerging problem at the OT level. And as we've seen, many organizations are concerned about it and are starting to do something about it and doing some of those activities that we've seen on the previous slide. So really important to do a risk analysis. We heard that from the call outs in the chat box. A risk analysis is about plotting. One way of doing it is to plot what's the impact if this event occurs. If it's got a really high impact, it shuts our factory down. That's pretty serious. That's a 5. It's got virtually no impact to us at all, would be a 0. And what's the probability of occurrence? Very unlikely to occur, so it's not going to occur, to highly likely will probably occur in the next 6 months. And you can look at each, what your vulnerabilities are and plot them on a graph of impact versus occurrence. And this can be a rough order of magnitude type calculation. You can just be quite, you don't need to be very scientific about the rating of the impact or the rating of the probability. You're just trying to differentiate between high risk and low risk. So anything that's obviously got a high impact to your factory and a high probability of occurrence would be a high risk item. And you've got to then start thinking about what your plans and activity are to move the high risk vulnerabilities are into the low risk areas, either by reducing their impact or by reducing the probability of them occurring in your factory. In fact, when I was in for my eye operation last week, some of you who attended last week may remember I had an eye patch on. That before the operation, I had a risk assessment by the surgeon. He was telling me all the things that could, the high impact things that could go wrong. He could damage my eye. I could get a serious infection post the operation. I could have a bad response to the general anesthetic. And he was reading them all out to me, and they were all high impact things. But I knew that, and with discussion with them, the probability of them occurring was really low. So they were falling into that box. So I was willing to accept that and move ahead with the operation. Now, if any of them had been falling into the high risk category, I might have wanted to discuss how do we mitigate that. You know, if I was if I was not able to take the general anaesthetic, I might say, well, I'd rather have a local anaesthetic and try to move my risk down. So you should do a risk analysis, and this is one way of doing it I found useful in the past. So some good cybersecurity resources that you should be aware of, that I've certainly found useful in the past, is the National Institute of Standards and Technology is a US site, and it has some great information on cybersecurity in a smart factory Internet of Things environment. So that's a great website to look for advice and best practices in cybersecurity in a Internet of Things smart factory environment. Another one to have a look at is the ISACA website. It has a section on control objectives for information technology, COBIT. Some great resources and information there on how to improve your readiness for improving cybersecurity in your organization. And a great read on cybersecurity, just this recently released paper, is a timeline analysis of cyber crime and cyber attacks during the pandemic. So it looks at all the recent cyber attacks that have happened in the last 2 years, and you know, why they occurred and what mitigations could have been put in place to protect against them. So these are three great resources to have a look at on cybersecurity. Paul, do you have any comments you would like to make on cybersecurity?
Hi, Billy. Sorry about that. Yeah, it's become a very big issue this year, the attack on the HSE, but also some very large multinationals, police departments in Chicago. So even the people that think they're very prepared aren't always, but yeah, simple things like password protection, making sure that all of the out-of-the-box systems that people buy that are connected to the internet, that all those passwords are reset. But it's with the more and more cyber attacks for Bitcoin and just getting into manufacturing companies and changing parameters on a robot, for example, so parts be made not to specification, and then they're held to ransom. So it's widespread across America. And they're looking for the weakest point. So don't be the weakest point. I think it's almost like having a burglar alarm outside your house, even if it doesn't work. It's a deterrent, but they'll move on to the next potential customer. So,
yep,
very important part of everybody's business strategy, and everybody needs to take it seriously, even if it's dropped out of the news again.
Yeah, I think they're great points, Paul. And I think that, you know, looking back at that list of mitigations that companies were taking, you know, looking at those and saying, are you applying any of those in your setting? Having a look at the NIST website, having a look at the ISACA website gives great information, and thinking how robust are you, then doing your own risk assessment. Where are the areas where you could have a high impact in your organization, and there's quite a high probability of it happening? Identify those areas, those resources, and start to think about what plans you could put in place to identify those. And this is a problem that everyone's facing. You've seen that 36% of executives were concerned about this. So it is a joint and shared problem through the whole of industry just now. And you should bring your equipment vendors along with you. You know, the people who supply the equipment in your factories. You know, they should be thinking, as you automate and connect those to your IT systems, how can they be protected? You gave the example there of the robots, Paul, you know.
But only 36% of people, of senior people, are concerned. It should be 100%.
Yeah, you're probably right. Okay, thank you.
Cheers.
So we'll move on to topic number 2 for this week, which is the concept of 3D printing, additive manufacturing. So the phrase additive manufacturing is commonly known as 3D printing. The phrase refers to any collection of methods that create items by adding material rather than removing it, from a starting mass by milling, grinding, or carving. So it's additive, we're adding to something to create a 3D object. Now, one of the significant effects of Industry 4.0 has been the rise of additive manufacturing to create complex parts. 3D printing actually has been about for quite a long time, but since the rise of Industry 4.0, we're seeing it more and more used to create really complex parts within industrial settings. And additive manufacturing and 3D printing is just using computer-controlled tools to make a physical 3D object in a variety of different materials. Originally, it was developed, as a rapid prototyping method in product design, so that a quick model could be created of the proposed finished product. So that was its original purpose, but it has evolved significantly since that over the last 10 years. So the 3D printing process, we would generally start with a 3D design file, a CAD model file, which could be from a design that's been created in a computer software itself, or it's scanned data from an actual physical object that exists. We then create a stereolithography file called an STL file. Then that is used to create some slicing data through a computer-aided manufacturing software. So then that slicing data, all those different layers that make up the 3D object, can be presented to the 3D printer, and then we end up with a physical object. And that's the standard process that is used in 3D printing technology. Now, we've seen a rise of 3D printed products, not just prototypes. And this has happened as more and more materials are available for us to create 3D printing to do additive manufacturing in a whole range of materials. These include plastics, ceramics, concrete, metals, and even human and animal tissue. Objects have all been created in these materials using 3D printing technology. It's more cost effective than injection molding for low volume parts. If you have low volume speciality parts you have to create, then doing it in 3D printing is probably more cost effective than doing it via injection molding. And it allows for complex and bespoke designs, really complex designs, really one-off scenarios. That's where it really comes into its forte. And basically, the basic way to think of it is, if you can design it, then you can 3D print it. And a few years ago, many companies were purchasing 3D printers and maybe not being sure what to do with them. But there are many 3D printing services now. So if you need an object created in a particular material, there are many companies now who specialize in providing 3D services, 3D printing services. So it's not something you always need to own, but it's a service that you can pay for, and it's a fairly increasing industry. There are different technologies used to create 3D objects via additive manufacturing, and you'll come across the terminology. I'll just put them down here so that if you come across them, you know you've heard of them: binder jetting, directed energy deposition, material extrusion, material jetting, power bed fusion, sheet lamination, vat polymerization. They're all methods, they're all processes that are used to create in 3D printing to create additive manufactured parts. And the materials that can be used. Now, there's a huge variety of materials now, which has hugely increased the number of products that can be created using 3D printing. We can 3D print with metals, with polymers, with ceramics, with concrete, with new materials, shape memory materials. So we can 3D print in a material that might change its shape depending on its environment, on the temperature, exposure to a certain chemical, to water, to pressure. So, and people have been using the term 4D printing for that, when a specialized material is used to create the 3D object, a material that can change its shape based on its environment and then return back to its original shape. Tissue, that's a key one, human and animal tissue. You can 3D print in that. And food. So maybe I'll go back to my whiteboard and maybe you can give me some examples of 3D printing that you've seen in industry. So I'll stop my share screen here and we'll maybe go through some examples that you have seen on 3D printed. So we put them into chat box, any examples you've seen in industry of 3D printing being used. And Dara, maybe you can help me out again and call out anything that comes into chat box. So 3D printing in industry, what have we seen?
So one here is for machine parts.
Machine parts, yeah. So that's a great one. You know, creating spare parts. I know that, and this is highly used in the automotive industry and in military air forces. Military air forces, in fact, have you know, where they have bespoke parts that go into their aircraft to cut out the whole supply chain problem. They will have 3D printing done to create some bespoke part in an aircraft, so they can actually manufacture it on the aircraft carrier or the remote airfield. So creating spare parts and tools and hand tools.
Another one, which I think you covered already, Billy, was the prototypes.
Prototypes, yeah, and that, you know, that was the very start of 3D printing, was how can we quickly and cheaply produce a prototype? And that's where 3D printing first came into its real forte.
Another one is prosthetic limbs.
Yep.
Can't say I've ever seen that printed now, though.
Yeah, no.
Really?
The whole world of medicine and creating components for human beings is a huge part of 3D printing. You know, we are really bespoke. We've mass produced, there's 8 billion of us on the planet, but no two of us have the same knee joint or the same hip joint or the same cranium shape or the same finger shape. So 3D printing has really revolutionized the world of medicine and creating bespoke parts for human beings.
Another one that we've started to see a lot more of now is around houses and the concrete extruders.
Yeah, I actually, I didn't know much about this either until it was only, I think about 2 weeks ago, I seen an article about a Chinese company who were printing houses in concrete. Through, you know, I was amazed, and they built like 10 houses in one day using this, using a concrete 3D printing system. Unbelievable.
Even I think I've seen it as well in Europe, Billy. A German family, I think it was German family, moved into the first 3D printed house in Europe there a couple of weeks ago.
All right, so yep, must look that one up. Any other examples of 3D printing in industry?
Another one we've seen is dentistry.
Yeah, dentistry. Yeah, again, bespoke. Your teeth are unique to you. No one else has the same teeth shape as you. You are a unique person, and the only way you can create that unique thing is using a technology like 3D printing.
I think that's everything now. This is an interesting one, actually, Billy, and I think it ties in a bit. So someone has said printing molds for injection molding.
Yeah,
And I wonder,
great.
is that actually possible? Because we talked a bit about how the kind of short and medium run with a 3D, with additive manufacturing might be more efficient. But if you're building something for an injection molding, would that work?
I think it would. I hadn't thought of that one, and it's a great example because, you know, creating these molds is expensive, right? And that's why 3D printing for a one-off object, you might not want to have to create a mold for it. You can just 3D print it. But 3D printing would offer a way of creating molds cheaper and quicker. So actually, I think that's a fantastic example that I'd never actually thought of.
Absolutely, I agree, because they're usually north of 10,000 or 15,000 euros or something to get made.
Yep. So think if you can 3D print it, then you've got the mold, then you can go in and do your create your millions of parts. So that's a great example. So they're fantastic examples that we're obviously all seeing some impact of 3D printing in industry. So I'll go back to my screen share now. So 3D printing, we're seeing it used in aerospace. In fact, we you know, we're speaking about examples that we're seeing in manufacturing, and one of the ones you gave me was, you know, about spare parts. So aerospace, absolutely, and especially in the aviation military are certainly using 3D printing to create spare parts and hand tools. Automotive, same reasons. In the car manufacturing industry, 3D printing has been utilized. The food industry is actually using it, as is, and healthcare and medicine. Healthcare and medicine is a huge area for expansion in 3D printing. And it's for that reason we are the bespokeness of human beings. Though there's 8 billion of us been mass produced on the planet, every single one of us is unique. And if we need some new dentures, if we need a prosthetic, if we need a knee joint, we need an elbow joint, that can be created bespoke for us using 3D printing. So the implications in medicine are actually huge, and the medical industry has really been revolutionized by 3D printing. We spoke about their architecture, building, construction. Somebody just gave examples of houses actually being constructed using 3D printing methods. Fashion, huge area there, possibilities there for creating bespoke fashion items. In the electronics industry, so we're seeing the use of 3D printing through a whole range of different manufacturing areas, and I think you captured most of them there on our whiteboard. So I just wanted to mention about 3D printing in medicine. So 3D printing really is widely accepted manufacturing technology now in the medical world. It's highly used. There are multiple 3D printed medical products in the market, you know, including implantable craniofacial implants. You know, people have had their whole faces rebuilt using 3D printing technology, kneecaps, surgical spines, surgical instruments. Huge amount of this going on in medicine just now. 99% of all hearing aid housings are now custom made through 3D printing. Pre-surgery printed anatomical models, really important for as surgeons plan their activities. You know, having physical models available to them is really helpful, as well as having the virtual digital twin. Having the actual model in your hand is really important. And researchers have 3D printed in 16 different types of tissue, which providing models for high throughput screening of new drugs. So they can 3D print organs and allow then for the testing of different drugs on those. And the implications for the future are that maybe we can actually 3D print an organ, a replacement organ for someone in the future. And we spoke about 4D printing, and 4D print is where we introduce new specialized materials that can change their shape based on their environment once we've created the 3D printing object. And all of these medical advancements, if this paper at the bottom here, you can look at that for some of the advances that we're seeing in medical science from 3D printing. So 3D printing resources, again, there's an overview of 3D printing technologies. That's a great paper that gives, published in 2019, but it gives a great overview of where we are at with 3D printing, how it can be used and how it is being used in many different industries. So have a look at that paper if you're interested in finding out more about 3D printing. Paul, any comments or anything you'd like to say about 3D printing?
Yes, Billy, thank you. There's lots of great examples. Of course, yeah, for the mass production of things, and you've got time to plan it. Perhaps other methods will be available, but certainly for bespoke, unusual things, prototypes, that it cuts out a lot of time to get a CNC machine set up to make a prototype part as opposed to 3D printing. It's yeah, it's a vital part of technology and just innovation generally.
Yeah, and I was, what really excited me was, you know, the idea of, you know, in the aviation industry, and I actually do some lecturing for some pilots on aviation studies, and the idea that they can get, you know, if they have a spare part that's required for an aircraft, you know, they're not having to look through some big supply chain to get that part, that could actually be manufactured at the airbase, at the airport for that aircraft, and they immediately have a spare part. I was amazed by that, and I think that's a fantastic advancement.
Yes, you know, the need to have thousands of spare parts all in the right location, the right place in the world. Yeah, if every aircraft hangar had this type of application, then yeah, it'd certainly be a quicker turnaround.
Okay. I'm going to move on to my, thanks Paul for those inputs. I'm going to move on to my last topic today before we go into our guest speaker on Dr. Ian Keaney on artificial intelligence. I just wanted to talk a little bit about big data. So I'll start off with a question for you guys, again, a chat box question. What is big data? Can anybody give me a definition for what big data is? Let me just put that into your into chat box, and I'll capture it on my whiteboard. So what is big data? When people say big data, what do they mean?
Well, I'll give you a definition while we wait, Billy. I would say big data is something that is an amount of data that is too large for someone to manually comprehend or manually analyze.
Too much to manually. And what do you mean? What exactly do you mean by manually analyze?
Well, say maybe me sitting down with my Excel spreadsheet, I probably couldn't understand it very easily.
Yeah. If you're the CEO of Facebook and you had over 3 billion subscribers, I could see that would give you a problem if you wanted to do some analysis on that data.
Chris says multivariate data.
Yep. When you've got multiple variables and you're wanting to do some complex analysis on that.
Sean says large and fast.
Large and fast, yep. The data's coming at you fast. You know, it's continually changing. It's got high velocity and there's huge quantities of it.
Another one is lots of clients, which I would take to mean lots of sources.
Yep. Lots of clients, lots of sources. All the data is coming from different places. You know, that's the Facebook example. You know, the 3 billion people feeding information in.
I think that's it as far as definitions of big data go.
So they're pretty good. I mean, look at, we've got well, the amount of data is more than you can manually analyze by yourself. Multivariable data, large data that's coming at you very fast, and where there's coming from lots of clients, lots of different sources. So that's our definitions of big data, and I think that's pretty spot on. So I'm just going to share again here. So the actual definition, or there are many definitions of big data, but one of the classic ones that was developed about 20 years ago was the 3 V's. So volume, velocity, variety. And I think we captured those in our whiteboard today. So volume refers to the amount of data you're getting. And of course, the definition of what is a large amount of data has changed through time as the size of my hard disk on my computer has changed through time. You know, it's got so that I've got so many photographs and videos now, I can't keep them on my laptop's computer hard disk, even though it's huge compared to what it was 20 years ago. I have to use a cloud service like Amazon to store all my photographs. So what is a large amount of volume does change. Our definition of that does change through time. Velocity refers to the speed at which data are being generated and processed. So the speed that the data is coming at you. And in an Industry 4.0 setting, that's really important because the data is coming at you very fast, real time, off the factory floor, and needs to be processed immediately to make those timely decisions on, does the machine need to be adjusted? Does the PM need to be done? What action do we need to take next? And we got it. Variety as well. We got that in our whiteboard examples. Variety refers to the number, the types of data that we're getting. Different data from different sources and different formats. It might be video, it might be audio, it might be numbers, it might be time related. All different varieties of data coming at us. So when we have the 3 things together, that's what we call big data. Now there are So we see when we've got volume, velocity, variety, then classically that's what people refer to as big data. So additional dimensions that some people refer to in big data are variability, complexity, and value. You know, variability refers to the variation in the flow rates of the data, but I think that's often captured in velocity. Complexity refers to the number of different sources, but I think that's already captured in our variety definition. And value is what companies need to understand the importance of using data to increase value. You know, data is only worthwhile if it increases value, if it helps us increase productivity, improve our efficiencies, as a benefit to the company, its customers, and society. That, you know, the data has to have some value. So big data does help enable artificial intelligence, and I'll be delighted to hear our next speaker's thoughts on this. You know, do we always need big data for artificial intelligence? And it can enable machine learning. So machine learning and artificial intelligence use data to help them make their decisions. Now, all this data that we have today is really exploded in the last 20 years as we have connected more and more machines and components to the internet. And I was thinking about, there's some graphics out there showing all the different things that are on the internet today, but I just thought, well, what's the simplest way to show this? And it's the number of human beings who are a thing on the internet. I first started using the internet in '97, and I didn't realize it at the time, but I was a member of an exclusive club of 200 million people at that time using the internet. Today, well, this chart only goes up to 2016, there's over 3 billion people have access to the internet. So today it's probably closer to 4 billion. Half the population of the world are using the internet. And that all creates data. That's one measurement of the expansion of data in society and industry. And social media has hugely increased the amount of data that's about in society and the need to create systems that allow us to process big data. You know, Facebook have over 2 billion users now, YouTube approaching 2 billion. They're all creating huge amounts of data. And so the need to be able to process this type of data is becoming more and more important. So the Internet of Things devices and smart factories generate high volumes of streaming data, and immediate processing is often required for time-critical situations. So that's given the rise of data analytics and big data in the smart factory. And also big data has been driven by the rise of social media as well. Of course, our big data, we can't store it on our laptops anymore. It's too much information being gathered. So most companies would store it on the cloud or on a multi-cloud where they're using different cloud providers and spreading the information over numerous cloud providers, or on a hybrid cloud where they use the cloud provider plus maybe their own internal servers to store data. And some companies are very sensitive about sharing some information out with their organizations and prefer to keep it within their own internal cloud and on their own servers. So of course, big data helps us make decision making, and it's about data-based decision making. That's what's key here, is we have all this information and data from our factories. We then can perform data analytics on it, which is using statistics to help us make decisions. And the rise of the data scientist has really been a big new function in the last 10 to 5 years. And that's an area that we've seen from our earlier polls that many of us are really interested in improving in our organizations. So data analytics helps us create models, produce machine learnings, produce AI, data mining, and visualizations. So it's about using statistics to make decisions. Now, there's a great paper here I've put a link into on really discussing big data, its dimensions, evolution, impacts and challenges. So I would really encourage you to have a read at that on big data. And also the European Union run a program called Edison, which looks at helping creating more data analysts in society so that higher education institutes are supplying a steady stream of data professionals, data science professionals, to help this need that so many of us have in our organizations now. So if you look at the Edison project, you'll see some great information on data there. So I'm conscious that we're running at 25 to now. So I'd like to now go on to our 90-meter poll today. So just a very quick poll this week, a yes/no answer. My company uses artificial intelligence or plans to use it in the near future. Yes or no? So if you go to your menti.com tab, you can answer that question using this code 22403107. So if you just enter that code in, maybe stick that code into chat, Dara, and I'll give you a minute or so to put that data, to do that yes/no answer on Mentimeter. Completely voluntary. If you don't want to do it, just leave it. So I'll give us 1 minute, then we'll have a look at that. Okay, I think that's the numbers in. So we'll have a quick look at the data. So I'm just going to share my screen again. So the question is, my company uses artificial intelligence or plans to in the near future. So 83% of you responded yes and 17% no. Interesting there that there's actually a big interest in artificial intelligence out there in our community. So I'd like to now move on to our guest speaker today, who is Dr. Ian Keaney. He's a machine learning engineer from Skellig AI. Dr. Keaney is a creative engineer with a passion for artificial intelligence. In 2017, he was named in the Sunday Business Post 30 under 30s most interesting people in Irish tech. So I'll hand you over to Dr. Keaney and Paul for a chat on artificial intelligence.
Billy, thanks very much. Hi, everyone. Billy, would you mind just moving on to my first slide? Sure, thank you. My name is Ian Keaney. I work in a company called Skellig AI. And what we do is we help organizations figure out where artificial intelligence has value in their business and how they can start getting back dividends from their data using AI. So when I'm talking to people, a lot of people get confused around what artificial intelligence really is. A lot of people seem to think that it's like humanoid robots or things with human-like intelligence and capabilities. That's very much not the case. What an AI is basically just an algorithm that can make just one basic decision. And from that decision, then it can then tell you what step you need to take. So essentially what you do is you show the algorithm, in this case, we treat the algorithm like a black box. And we show the algorithm some data, And the AI then decides, based on that data, based on what features it detects in that data, what you should do next, what that data represents. So in this context, what we mean by data is data can be anything that information is stored in, any form that information is stored. So that could be the likes of an image, that could be a video feed or an audio feed, like what maybe your, if you got a Amazon Alexa in your home, or your iPhone Siri. Or it could also be like tabular data, so spreadsheets, what you're used to looking at in Excel. And it takes that data and it tries to identify features from what it's seen before to make this decision. Now, the decision is essentially a decision we train it to make. And it only has the ability to, each AI only has the ability to make just one single decision. And it learns how to make this decision from previous experience. So that's where the role of large data sets come in. And that's, so by showing it historical examples of data sets, it can then learn from that what worked, what didn't work, what was correct, and learn how to make better predictions in the future. So to give you an example, Billy, would you mind moving on to the next slide? Thank you. A really great example of a use of AI in industry at the moment is something like where you have a utility company trying to predict when clients are going to leave them or not. So in this case, we have an example of a utility company has, they've collected data on their client, where they live, their occupation, so they can estimate what type of salary, what kind of rent they're probably paying. They can figure out what kind of means this person has and how long they've been using their service. And from that, then they can, when they feed that information into the AI will then predict whether this person is likely to churn or not, or when they might churn. So they might churn in the next 3 months, or it might be within the next 6 months, or there might be a very sticky client. The AI might determine that this customer isn't really price sensitive and has a personality that they don't really want to go through the hassle of changing provider. And that's important because the cost of acquiring new customers is much greater than the cost of retaining your current clients. So that can help a company just be a lot more efficient in their sales process. Another example, Billy, can you move on to the next slide? Is just using like cameras to be able to detect what's in an image and what's happening in that image. So in this case, we just have the AIs detecting strawberries in this image, and it's indicating which ones are ready to harvest and which ones are not ready yet. But that can be generalized to a lot of other things. There's a company in Dublin called Evercam that have a camera system used on construction sites. And what they do is they can detect when lorries are coming in on site and what types of lorries are coming in on site. And by doing that, they can record how many loads of stones are arriving on site, how many loads of concrete are arriving on site. And that then allows the construction company to keep a better track of what's coming and going. And they use that then to settle disputes with providers, where a provider might say, oh, well, we sent 15 lorries of stone, and the construction company might say, well, we only recorded 12 lorries of stone. So this gives them a record of saying, actually, no, here's the evidence of how many lorries came in. So I know the format of this is going to be more discussions. So I think I'll open up to questions. If maybe Paul, do you have any questions there?
Yes, Ian, thank you for that. Some great examples. But I always think that one of the examples of AI that people use perhaps every day sometimes I have a problem spelling certain words like sincerely. I don't know why. And built into Word or any of your Outlook, it will actually say, did you mean, and correct your spelling for it, because it knows perhaps what you thought you meant, but it knows the most likely answer was the correct spelling. But yeah, AI has been around since the 50s. No, it's not really a new thing, but what's different about it now, and what's making it more useful?
Right. Yeah. Yeah. So we've all kind of grown up with this idea of the existence that AI kind of is was sitting in someone's lab somewhere, but it's only really since 2012 that it's really properly infiltrated our lives. Now the reality is that it was always there in small pieces, but since 2012 we had a much bigger, essentially an AI boom. And what happened at that point was a lot of the techniques that we use today, they require two things that kind of came together around 2012, which was access to computation power. So access to powerful enough computers to run AI algorithms and to train them. And the large data sets large enough to basically train those AI algorithms. So that really happened in 2012 when the emergence of cloud servers meant that anyone could then rent high power computation power for quite a reasonable price instead of having to house and maintain their own servers. And then it was in 2009, Google released the very first Imagenet Dataset, which was the first collection of images, and it's about 14 million images. So it was when those things kind of came together around 2012 that practitioners really started to find more useful and more obvious uses for AI.
So what were the good things that AI is good for then? What were the new things that emerged then? So
what AI is really good at is doing very simple tasks, but at a large scale. So tasks that it typically takes a human less than a minute to do. So if you consider monitoring security cameras, where like traditionally you would have a team of people looking at security cameras to detect what's going on there, and it takes a human just a couple of seconds to figure out what's going on there. So that kind of simple task is really good for it. Like AI is really good at, but it can do it at a much larger scale than in a lot of situations that humans could never do.
Okay, but do you need a lot of data?
So traditionally, yes, but there's new techniques coming out all the time that's reducing that need. That's dependent on the problem that you're working on, really. So in some cases, you might need a couple of 100,000 examples of data, which can be quite a lot to try to collect. But more and more, we're seeing cases where now with new techniques being developed, where you only need maybe 50 to 100 cases, or there is an example of a solution that I was building there 2 weeks ago where you actually only need 5 to 10 examples. So there are definitely systems that you can build to be very effective with small amounts of data, and as time is going on, more and more solutions are becoming like that.
So it's becoming easier to AI. I mean, it's the whole industry for everyone knows, they need to get involved, and AI is becoming closer. So what's stopping people adopting it? What's still the roadblocks, or is it theoretical?
Yeah. So what we've found is every company has different barriers in their way, but they're all kind of break down to the same thing, to the same couple of things anyways. the first one is a lot of businesses, they don't fully see where the applications lie in their own industry. So and how they can get value from that. So that's really the first thing. Then the next thing is the cost, and it's rarely actually the financial cost, but it's more the cost to it's more the disruption to business. I think Billy, I think said something earlier about if you have to shut down operations to implement something into your business, then that's not about the financial cost to your business. It's about the operational cost. Like, so if you're running a manufacturing line, if you have to shut that down, that means you're going to have less product to sell. Does that mean that you're going to have shortages? Does that mean that your clients won't get the orders that they want? So it's dealing with those type of operational problems. And then there's always a little bit of risk with adopting these new techniques. Now, in general, most AI systems will on very specific tasks will outperform human level performance. But what happens when it goes wrong? People aren't really comfortable with that yet, and they're still trying. They're still coming around to that concept.
Just trust issues, but
yeah. So that's a bit of an issue. So
can you convince them with some real examples of, where it's, particularly for Irish SMEs, but where this is delivering real success, and where they're actually seeing in value, in financial and to the business?
Yeah. So what we've noticed is that if you are looking at adopting this technology, don't go for the very big promising projects, because they generally take take quite a lot to implement into your business. So they'll cost you a lot to invest into, but also like they tend to disrupt your typical operations. So start off by looking at the smaller projects, seeing how you can, with less cost and less risk. And when I say cost, again, I mean less disruption to your business and less risk, how you can get a little bit of value out of an AI system. Okay. So examples that we've seen work quite well in doing this is if you're automating paperwork, that can work really well, and that doesn't require a lot of operational disruption. Or something else would be maybe doing demand forecasting, so you can maintain more accurate supply in your warehouse.
Okay, that would be you're doing a workshop with us in October, aren't you, about how that can be applied to?
That's right. Yeah. So in that workshop, we'll be talking more about how we'll be going into more detail about the obstacles that you will hit and how to get around them, and basically and give you a sense of what type of value you can really expect from these solutions.
Okay, brilliant. And well, thanks a lot for your time today. I think we're running a little bit late. I want to cut you short, but I'll hand you back over to Dara. But thanks a lot for everything today.
Right. Thank you.
We'll look forward to speaking to you again soon.
Fascinating conversation there. Lots of questions in the chat box. So Dara and I will have a look at those and see if we can get some answers to them. So I'll just wrap up. So just to let you know, there are a number of courses available from Skillnet. They're all advertised on the Skillnet website on the 23rd of September and on the 25th of November. Dr. Salim from IT Sligo will be running a class on Industry 4.0 on behalf of the Skillnet program. So he's going to do a real deep dive into Industry 4.0. We've just kind of skimmed the topics in the last few weeks, but Dr. Salim will do a deep dive in 23rd of September, 25th of November. Dr. Ali, who was our guest in on webinar 1, will be running his fundamentals of IoT for SkillNet, and that will be on the 16th of September. Dr. Ian Keaney, who we just heard from, his workshop on AI business strategy will be running on the 8th of October. So that'll be a fantastic course to attend. If it sounds like a lot of you are really interested in AI from our Mentimeter survey earlier. And lastly, we will be running a class on the 30th of September on virtual and augmented reality for industry from Patrick Liddy. So all of those courses are available for booking and viewing on the Industry 4.0 SkillNet website, www.industry4skillnet.com. So we've looked today, we've recapped webinar 1 and 2, we had a look at cybersecurity, we had a look at 3D printing, we spoke about big data, we done our Mentimeter survey, and it sounds like we're all very interested in artificial intelligence. And Dr. Keaney gave us an overview of artificial intelligence, and his class is in October for those that want to find more about that. So call to action is for this week is for you to do a cybersecurity risk analysis, plot your probability of impact versus probability of occurrence, and consider actions to reduce your high risk items, i.e. the things that might have a high impact and a high probability of occurrence. And benchmark, find out what your competitors are doing, and that will give you some idea where to focus your efforts. So that's your call to action for this week. I'll close with a quote. Today, manufacturing is changing faster than ever before, and the drivers from this include globalization, individualization, time to market, and sustainability. And that's from Brian Holiday, Managing Director of the Digital Factory. So webinar 4 next week is our final webinar. We'll look at future trends, and our guest speaker will be Brian Clooney from KUKA Robotics. So stay connected. You can visit my website in www.billyscofield.ie. You can connect with me, Billy Schofield, on LinkedIn, or you can email me at billy@billyscofield.ie. So that's the end. Thanks for attending this week. Any closing remarks, Paul?
I would just like to ask everyone to please fill out the reaction to learning form. It's there in the chat, and it'll be available through an email later as well.
Yeah, thanks, Dara. Good point. Thanks, Billy, and thanks, Ian. I think a good cross-section today. A lot of interesting chat. So thanks everyone for attending, and hopefully see you next week for the final part in this series, which we'll be continuing on Tuesdays after that, with similar but different themes. Okay, thank you very much, everyone, for attending.
Thank you. Bye.